Slide 1. Obtaining Laboratory Services. Module 5 of the MARLAP training course. Slide 2. Obtaining Laboratory Services. This module of the online MARLAP training course will address obtaining laboratory services. MARLAP Chapter 5 addresses considerations for obtaining laboratory services. This module will also present material from Appendix E of MARLAP, Contracting Laboratory Services. Appendix E addresses similar topics, but it does so more extensively than Chapter 5. It includes topics such as multi-agency contracting vehicles, the process for solicitation of work or the request for proposal. This includes proposal requirements and the proposal evaluation and scoring procedures. Appendix E continues on to address the award of work, important aspects of the work such as the duration of contract and period of performance, milestones, and finally contract completion are all addressed in Appendix E. Slide 3. The importance of technical and contractual specifications. Contract specifications. The contract specifications capture analytical requirements in a concise format. This is information needed to help the laboratory select analytical protocols that both will be appropriate and meet the project's needs. The contract specifications also verify that project planning documents contain all the information required for the laboratory to select and implement appropriate analytical protocols. And finally, the contract specifications identify the laboratory's responsibilities for documentation that will be needed to support the process of data verification, data validation, and data quality assessment. Slide 4, the procurement cycle. Note that MARLAP's procurement recommendations generally conform to the Federal Acquisition Regulations, or FARs. Although the FARs do not apply to states, universities, or private sector purchasers of analytical services, most organizations have, or at least they should have, comparable requirements or regulations. While these may differ nominally in their formal structure or their naming, they should strive to accomplish similar goals of obtaining analytical services that meet project requirements for a fair, competitive price. The flow diagram on this slide summarizes key steps in the procurement cycle. It references the specific parts of Appendix E that discuss each item. Project planning is first completed by the project planning team. Section E2 of MARLAP talks about the procurement process used to communicate requirements to potential laboratories. This includes the processes used to select and reward the procurement and carry out and complete procured work. This step requires the preparation of a statement of work, or SOW, or an equivalent document that contains the information and requirements identified during project planning. Section E3 of MARLAP addresses preparation of a request for proposal, or RFP, or an equivalent document that reflects the requirements of the SOW. The SOW is sent to potential laboratories. Section E4 of MARLAP addresses the processes used to receive proposals, while Section E5 of MARLAP describes the process used to review, evaluate, and score proposals received, as well as audits and other measures used to collect information from potential bidders. Based on all of this information and using criteria in the procurement process, Section E6 of MARLAP describes the award of the work. Section E7 of MARLAP continues on to address the actual performance of services by the contractor laboratory, including periodic evaluation of contractor services as defined in the SOW. Finally, Section E8 of MARLAP describes processes used for contract completion. Slide 5, Procurement Options, MARLAP Appendix E2.2. When procuring analytical services, there are several solicitation types that may be used. The first is an invitation for bid, or IFB. IFBs are usually used for off-the-shelf services or products where there is no need for customized or tailored specifications or approach. This is not very common for laboratory services. A solicitation for proposals, solicitation for offers, is issued under sealed bid procedures. This may be a two-step process. First, bids are narrowed to identify and eliminate those that are not able to meet specifications or that are technically unresponsive. The second step is then strictly based on cost. It involves only those laboratories that will be able to meet specifications. So in the end, this process is competitive and is awarded based solely on cost. The resulting contract is fixed price. A second type of solicitation is the request for quotation, or RFQ. This solicitation is for technical and price quotations regulated under Federal Acquisition Regulation, Subpart 12, Acquisition of Commercial Items, or Subpart 13, Simplified Acquisition Procedures. The maximum estimated price cannot exceed the Simplified Acquisition Threshold, or SAT, of $250,000. There is a set-aside for small businesses when two or more small businesses are available that can provide the services. Although the competitive bid process is primarily based on cost, it may rely on best value as well. RFQs are best suited where requirements can be readily and clearly defined in advance and usually results in a fixed price contract. The procurement vehicle used for RFQs is a purchase order, or PO. The next slide will talk more about POs. Federal government POs are limited to the SAT of $250,000, although the maximum size of purchase orders may be limited by the organization. Purchase orders between $10,001 and $250,000 are automatically set aside for small businesses unless a justification to the contrary can be made. A micro purchase order, or MPT, is authorized under the FAR for purchases below $10,000. No justification or competition is required. Note that the threshold limits provided in this training module were current as of the end of 2020. A third type of solicitation is the request for proposal, or RFP. Requests for proposal apply to proposals to establish contracts under FAR's negotiated procurement process. It is suitable for procurements where the approach must be flexible or tailored to circumstances that cannot readily be defined in advance. Negotiations may take place with firms who submit proposals in a competitive range. This type of solicitation generally addresses major long-term contractor support, for example, support lasting several years. It relies on a competitive bid process based mainly on technical capability, or best value, rather than on price alone. Slide 6. Procurement options continued. MARLAP section E 2.2. On this slide, we continue our discussion of RFPs. Several types of contracting vehicles may be used with RFPs. One is the purchase order. Purchase orders usually specify a not-to-exceed limit for purchasing. The FARs, however, establish the SAT ceiling for purchase orders at $250,000. Purchase orders are limited to small needs without a formal request. For example, they may be used to purchase a limited number of sample analyses or services. Purchase orders may also be used to purchase supplies and less costly instruments or equipment. And finally, purchase orders may be issued on a fixed price or time and materials basis. The second contracting vehicle is the fixed price contract. A fixed price contract is generally the preferred contracting vehicle for analytical services. With fixed price contracts, the risk for performance lies entirely on the contractor. Failure to perform or complete the contract means that the contractor will not be paid. Fixed price contracts are best suited to situations where the specifications and schedule are known and there are few ambiguities in the requirements. Several types of fixed price contracts are available. Cost reimbursement contracts are suitable for research or other services where it may not be practical to specify the approach or schedule without ambiguity. Cost reimbursement contracts are also well suited for long-term work. Contractor costs will be reimbursed, so the contractor bears little risk of failure as long as they make diligent progress. Time and materials. Time and materials contracts are probably the least suitable option for analytical services. They are generally best suited for research or other services where it may not be practical to specify the approach or the schedule without ambiguity. Time and materials contracts are also better suited for long-term or ambiguous requirements. Contractor costs for time and materials will be reimbursed, so the contractor bears little risk of failure as long as they make diligent progress. Basic Ordering Agreements, or BOA. BOAs may be established with vendors under the Federal Supply Schedule with the GSA or by individual agencies. BOAs permit faster ordering because many of the prices, terms, and conditions are already established. BOAs establish the terms and conditions for indefinite delivery requirements, that is, unknown quantities of task orders or analyses, or unknown delivery dates for analyses or task orders, or both. The BOA defines the analytes, costs, methods, APSs, MQOs, and any other parameters required, as well as required sample throughput and turnaround times. An agency can use a BOA to send samples to one or several vendors, depending on needs and laboratory capabilities. Indefinite delivery, indefinite quantity, or IDIQ contract. An IDIQ contract can be used to procure supplies or services. It does not specify a firm quantity that will be issued and delivered during the period of the contract, as do delivery orders or task orders. The basic contract specifies the contract types authorized. Cost reimbursement or firm fixed price contracts are possibilities. Each task order will identify the specific contract type utilized. Other considerations. The non-competitive procurement process is used to establish qualifications, capabilities, costs, capacities, and other requirements. Federal acquisition regulations specify procedures and justifications for limited competition in FAR Section 6.302. Lack of funding or inadequate advanced planning, for example, are insufficient justifications. Generally, there must be an unusual or compelling urgency to use a non-competitive process. This could include a situation where the contractor possesses unique capabilities, such as a patent holder. It might also be used in the case of national emergencies. Non-competitive procurement process rules apply to types of procurement above the micro-purchase threshold of $10,000. The FARs and good business practices require competition whenever possible to obtain the best value, cost, and performance. Modifications to an existing contract. An agency may expand or extend an existing contract to cover additional authorized work. The terms and conditions must implement options already built into the contract, and the approach must meet a need that is consistent with the type of contract already in place. For example, a method for sample processing may be added that is similar to work already covered. Consider a contract with Acme Consultants to evaluate SOPs for tritium. This contract may not be modified to purchase tritium analyses without justifying sole source. However, if the original contract was for 100 tritium analyses, and it contained a provision that the government could optionally order 100 strontium analyses, a modification may exercise that option. The contract modification may be unilaterally imposed by government or bilaterally agreed upon by both parties. The government, however, always reserves the right to modify the contract unilaterally. If the modifications change the price, the contractor may seek fair and equitable adjustments in price. Many modifications are purely administrative and implement changes to terms and conditions. The name of the technical contact would be an administrative change, for example. Modifications to existing contracts may require sole source justification, especially if there's a change to the scope or quantity or the statement of work. Slide 7. Statement of Work Technical Specifications. MARLAP recommends preparing written technical specifications, which could be referred to as a statement of work regardless of whether the services are to be contracted out or performed by an organization's laboratory. The SOW should contain the Analytical Protocol Specifications, or APS, that address the Measurement Quality Objectives, or MQOs. The development of APSs, which include MQOs, is described in detail in MARLAP Chapter 3. These protocols are incorporated into the relevant project plan document as described in MARLAP Chapter 4. A Measurement Quality Objective, or MQO, is a qualitative or quantitative statement of a performance objective or requirement for a particular method performance characteristic. Under MARLAP, the single most important parameter for each radionuclide matrix combination in the SOW is the required method uncertainty at a specified concentration, or U sub MR. Although the required method uncertainty is generally the most effective MQO type for assessing whether an action limit may have been exceeded, other MQOs are used, including the minimum quantitation limit, or MQL, or the required detection capability, generally referred to as the minimum detectable activity, or MDA, or the minimum detectable concentration, or MDC. Other MQOs may complement these, including analyte concentration range, specificity, and ruggedness. Note that defining multiple MQO types may result in conflicting or ambiguous requirements. Thus, a single MQO type should be designated for each analyte matrix combination. In addition to MQOs, the APS should specify items such as the type and frequency of quality control or QC samples, the level of performance demonstration needed, the number and type of samples to be taken, turnaround times, and specific details for the required data package. Slide 8. SOW Technical Specifications, MARLAP Section 5.3. As mentioned, project plan documents should contain the technical requirements needed to develop an SOW. They should specify the MQOs and any unique analytical process requirements needed to prepare the APS. The level of specificity in the SOW and APS must be detailed enough to result in radioanalytical method performance that meets a project's needs. Wherever possible, MARLAP recommends against requiring specific radioanalytical methods. Instead of prescribing specific methods, MARLAP recommends using performance-based methods. The Safe Drinking Water Act and Clean Water Act, however, are notable exceptions. When laboratories perform compliance measurements of drinking water or clean water, they must do so in strict compliance with the approved methods listed in regulations. Such methods are generally referred to as prescribed or promulgated methods. This contrasts with typical organic and inorganic chemistry methods where Radioanalytical methods are only exceptionally prescribed by federal regulation. Performance-based methods are methods that are selected by laboratories to specifically meet program requirements. Often laboratories modify existing methods or even develop new ones. Note, however, that all methods, prescribed or performance-based, should be validated for the analyte matrix and activity range expected for the project prior to use. Let me repeat what I said above. MARLAP recommends against requiring specific radioanalytical methods unless methods are prescribed by regulation. Consider that a project may be raising its risk by specifying a particular method in an SOW APS. All too often, methods are prescribed for use beyond their scope and applicability. For example, drinking water methods are too often prescribed for solid matrices. Less scrupulous laboratories may attempt to be responsive and agree to this request. This could also arbitrarily lead to a qualified laboratory that maintains a well-validated method that ideally suits a project's needs to be non-responsive to the request. In both of these cases, data quality would suffer. Slide 9, SOW Technical Specifications Continued. MARLAP Section 5.3. Because radiochemistry laboratories must validate methods, radiochemistry SOWs and APS must clearly define what laboratories need to do to demonstrate that they are capable of meeting the technical specifications in the RFP. These include method validation and documentation requirements. Under MARLAP, Chapter 6.6.3, a tiered approach to method validation is used to take into account whether or not the laboratory has methods that meet the APS specification. Please stop and take a few minutes now to read through the attachment C on page 5 of the example APS in Module 5 handout. It outlines requirements for method validation for a hypothetical project involving strontium-90 in milk. In looking at attachment C, you'll see that if the laboratory has previously validated the method for a required analyte matrix and activity level, method validation level A would require no additional validation. If the laboratory has a method in place for a similar matrix, level B would apply, and 3 replicates are required at each of 3 test levels. If, however, the laboratory must modify or develop a method that can address the milk matrix, for example, more extensive validation, such as that specified in levels C, D, or E, may be required. We'll discuss method validation in more detail in Module 8. Also note on page 1 of our example APS, levels A, C, and D are listed as acceptable, while level B is not. Here, project planners appear to have felt that more extensive validation than level B was needed to ensure adequate laboratory performance on milk matrix. Other items are frequently specified in the SOW APS. Results from proficiency evaluation programs, or PE programs, are often required. PE programs are used to demonstrate laboratory capabilities. They involve the analysis of unknown samples. They're not a replacement for, but are used to complement method validation. A number of PE programs are available for typical environmental media and radionuclides. Several government-sponsored programs are available at no cost to the laboratory. These include the Department of Energy's Mixed Analyte Performance Evaluation Program, or MAPEP. MAPEP produces PTs containing a significant number of radionuclides in typical environmental matrices such as soil, water, air, vegetation, and the like. The program, operated out of the U.S. Department of Energy Radiological and Environmental Sciences Laboratory in Idaho Falls, Idaho, is open to contract laboratories doing direct work for the DOE and to laboratories that support DOE missions, including state laboratories involved in DOE site remediation, anti-terrorist programs, and nuclear power laboratories. The URL for WRESTLE is https://www.id.energy.gov/RESL. The Food and Drug Administration's Food Emergency Response Network, FERN, supplies member laboratories with performance evaluation program samples. This program is open only to state FERN member laboratories. One government-sponsored program for which participating laboratories must pay is the National Institute of Standards and Technology, or NIST, Radiochemistry Intercomparison Program, also referred to as NRIP, N-R-I-P. The URL for this program is www.nist-projects/NIST-radiochemistry-program-NRIP. There are also commercial entities that maintain accreditations to offer various PE programs for cost. Eckert & Ziegler Analytics offers PTs in environmental monitoring and nuclear power PT programs and is open to any paying laboratory. The URL for Eckert & Ziegler is www.ezag.com. Environmental Resource Associates offers drinking water samples related to EPA's Office of Water, Safe Drinking Water Program, and the NELAC Institute, or TNI, drinking water requirements. It is open to any paying laboratory. Although each laboratory's responsibility is to ensure that PE programs maintain proper accreditation, projects should also verify the accreditation status of laboratories they use and whether the PT program is technically applicable to their project. SOWs and APS may also include requirements to provide evidence that the laboratory has previously performed work under similar contracts in the past. Sample delivery requirements should be addressed. Page 2 of our example APS lists field sample preparation and preservation and sample receipt and inspection. These requirements address sample chain of custody and the integrity of sample at the point in time that the laboratory took possession of the sample. The SOW and APS must also address quality management system requirements. Attachment B of our example APS addresses an important requirement for the laboratory's quality management system. It defines the quality control samples that the laboratory must run to provide evidence that analytical processes will meet MQOs. Slide 10. SOW APS Technical Specifications. MARLAP Section 5.3. MARLAP Section 5.3.1 addresses analytes. The analyte list is generally compiled from information obtained from site process history and or from investigative studies. So it should list the radionuclides or radionuclide parameters of interest and the expected concentration range for these when available. It should also list possible chemical and radionuclide interferences, including their expected concentration range when available. For example, we could designate strontium-90 plus possible strontium-89 and fission products, along with interference from calcium, magnesium, barium, and fat molecules. Section 5.3.2 of MARLAP addresses matrix. The SOW should contain unambiguous descriptive matrix designations and not a general form of the matrix, so that the laboratory can select an appropriate method. In our example, we talked about raw cow's milk fat content to vary. Consider that a general description, such as liquid, describes drinking water or oil, or even elemental mercury, matrices that would pose very substantially different challenges for a method. A descriptive matrix will be specific enough to identify characteristics that could substantially impact method performance. If we were just looking at a water, for example, an adequate matrix description might be brackish groundwater with sodium chloride content up to 7%. Slide 11. SOW APS Technical Specifications. MARLAP Section 5.3 continued. Stop and take some time to look over the pages 1 and 2 of our example APS for milk being analyzed for strontium-90. What does the APS tell us about the analyte list, the expected concentration range, possible interferences, analysis limitations, and matrix. When you have identified these items, please resume the recording. On page 1, we see the following information. The analyte list shows a single radionuclide, strontium-90. This is an APS that specifically addresses testing for strontium-90. Notice that APSs may have been prepared for other tests, such as gamma spectrometry, for example. The expected concentration range for samples is listed as 1 to 50 picocuries per liter. This both informs the laboratory about the method they should use, but just as important, however, it will keep them safe and help them plan for adequate contamination control. Possible interferences are listed as fresh beta-emitting fission product nuclides if purification steps are inadequate or non-existent. Possible fission products include strontium-89, barium-140, lanthanum-140, and possibly yttrium-91 if less than 1 week has elapsed between active fission and chemical separation. The laboratory must therefore select a method that is specific enough to measure strontium-90, which is also a beta emitter. We'll talk more about this when we mention specificity in a moment or two. The fourth item is analysis limitations. Analysis limitation specifies perform direct measurement of analyte. Analysis of progeny is allowed if radioactive equilibrium is established at the laboratory from freshly isolated parent. When strontium-90 decays, it becomes yttrium-90, which itself is a beta-emitting radionuclide that will interfere with the strontium-90 measurement. The concentration of yttrium-90 will change until it comes to equilibrium with strontium-90, which takes place over a period of about 2 to 3 weeks. The APS ensures that the method used will take this into account. Thus, the laboratory may use a direct analysis method, measuring strontium-90, or an inferential determination of strontium-90, for example, measuring its decay product after a known period of equilibrium, once that equilibrium is established. Clearly, preparing the APS requires technical expertise of a radiochemistry expert. The fifth item is matrix. Here, the matrix is defined as raw cow's milk. Section 5.3.2 of MARLAP addresses matrix. The SOW, as we've said before, should contain a descriptive and not a general form of the matrix. A general description of a matrix might be liquid or even milk. Here, the SOW more specifically refers to raw cow milk because the fat content of milk from different animals varies. Similarly, that of processed milks may also vary. Either of these could substantially impact method performance. Remember that the goal is to provide the laboratory with enough information so that they can choose a method that is appropriate for the project. Slide 12, SOW Technical Specifications. MARLAP Section 5.3 continued. Section 5.5.3 of MARLAP addresses MQOs in the SOW and APS. The first of these is the analyte concentration range. This is important so that the laboratory knows the activity range to expect and can plan the size of the sample to process and the sample count time, as well as any contamination controls that may be necessary. The MQOs include the required method uncertainty at a specific concentration. As we've said earlier, Chapter 3 of MARLAP recommends using the required method uncertainty wherever possible. The required method uncertainty defines the level of imprecision or uncertainty to expect from a method in samples of a given concentration, generally the action level concentration. This concentration is incorporated into the statement of the required method uncertainty. Our example specifies an MQO for method uncertainty of 0.5 picocuries per liter at 8 picocuries per liter. We could read this as at or below 8 picocuries per liter. When the sample activity is above the action level, we use a relative uncertainty, the required relative method uncertainty of phi sub mr. In our example, the APS specifies an MQO of 6.3% above the action level. The required relative method uncertainty is simply the required method uncertainty divided by the action level concentration, expressed in percent. Although other possible MQOs are discussed in Chapter 3, they're not needed in our APS. One of these would be the minimum detectable activity listed together with the critical level. When expressed in terms of a volume or mass, we talk about the minimum required concentration, or MDC. The MDA or MDC are measures that describe a method's detection capability. This is a generic or a priori value for that specific method. The critical level, in contrast, is a measure of the detection threshold for a specific measurement of a specific sample. It tends to be about 1/2 of the MDC concentration. Using the MDC as an MQO is in general most appropriate when a radionuclide is not expected to be present in samples. The minimum quantifiable concentration, or MQC, is the concentration in a sample for which a method will produce a relative measurement uncertainty, generally 10%. Many people often conflate the MDC and MQC concepts. They are very different. The MQC might be more applicable to cases where we would be averaging values and want to minimize the uncertainty of any given result to a specific level of 10% at a concentration. The MQOs also include specificity or method specificity. The method specificity to isolate and detect only the analyte of interest is defined as the ability of the method to measure the analyte of concern in the presence of interferences. In our example, we see the following: strontium-90 plus possible strontium-89 and fission product interferences. The laboratory needs to select an appropriate method that combines chemical separations and a detection technique to accurately determine the strontium-90 in the presence of other beta-emitting substances such as strontium-89, while simultaneously addressing radioactive interferences such as yttrium-90, barium-140, lanthanum-140, other fission products in the sample. Yet another MQO listed is for method ruggedness. Method ruggedness is defined as the relative stability of the method performance for small variations in method parameter values. This would include matrix variations, change in analysts, slight changes in method steps, while maintaining the quality and performance. For this reason, the APS lists a specific matrix, raw cow's milk, fat content to vary, instead of a general one. Slide 13, SOW APS Technical Specifications, MARLAP Section 5.3 continued. MARLAP Section 5.3.4 states that unique analytical process requirements should be stated for sample preparation, chemical processing, or radiation or atom detection. Other critical technical and quality specifications include QC samples and PE program requirements, which are addressed in MARLAP Section 5.3.5. Specifications should be provided and should include the type of QC samples and the frequency of their use. The specifications should also address requirements for participation in performance evaluation programs, such as those mentioned in Slide 9. Participation should also include the analytes and matrices of interest. The criteria for acceptable performance on batch QC and performance evaluation samples should be based on project MQOs. This will provide information that the laboratory is capable of meeting project measurement quality objectives on an ongoing basis. MARLAP Section 5.3.5 discusses radiological holding time and turnaround time, or TAT. The radiological holding time is defined as the time between the date and time of sample collection and the date and time of the analysis. Specifications for the radiological holding time are generally related to the half-life of the radionuclide and how that impacts the radioanalytical method used, requirements for detection capability, and interfering radionuclides and decay products. The turnaround time is defined as the time from receipt of samples at the laboratory until results are reported to the project manager. Turnaround time specifications will vary according to project-based needs for the receipt of analytical data. For example, if sampling for I-133 from a nuclear plant vent, the radiological holding time will be very short since the half-life of I-133 is only 20 hours, while longer turnaround time may be established based on the project's need to use the data or on other tests being performed on the same samples. Other requirements would include the number of samples expected and schedule for their receipt. This is discussed in MARLAP section 5.3.7. The SOW should state the estimated sample load by schedule, if possible. This information is important to evaluate the radioanalytical method proposed and the allocation of staff and equipment resources. Also, in order to ensure that they can meet TAT commitments, commercial laboratories must plan sufficient sample processing capacity for multiple clients sending samples at the same time. MARLAP section 5.3.8 addresses quality system requirements. If the organization or project requires the lab to use a certain quality system process, details must be included in the statement of work. And finally, MARLAP section 5.3.9 addresses the method, selection, and approval process. The method selection and approval process should be stated in the SOW. This includes the method validation requirements for each of the radionuclides and matrices and the acceptable criteria for each of those. Documentation requirements for method selection and validation should also be included, as well as the Technical Evaluation Committee's evaluation process for the method selection and validation. Slide 14, Request for Proposal, General Contractual Requirements. MARLAP, Section 5.4. The RFP should include the actual statement of work. Additional specifications not included in the statement of the work may include quality, administrative, statutory, and regulatory requirements, and proposal instructions, either technical and cost business related. In general, any specification that will impact work performed following award of the contract should be addressed in the contract. Slide 15, Laboratory Selection and Qualification Criteria. Technical Proposal Evaluation, MARLAP Section 5.5. The evaluation of the technical proposal is addressed in MARLAP Chapter 5.5. Several items worth noting are: do not consider cost in the technical evaluation process. Scoring and evaluation schemes must be established prior to RFP distribution, and the evaluation scheme should be distributed to all prospective laboratories. The evaluation itself is performed by a Technical Evaluation Committee, or TEC. Agency personnel initially involved in establishing a new contract and initiating the laboratory selection process may consist of the contracting officer, who is generally administrative and non-technical, or the contracting officer's representative, who may be a technical staff person advising the contracting officer. In any case, the Technical Evaluation Committee is a team of technical staff members that reviews the proposals sent by the laboratory. chairperson is designated to provide oversight of the evaluation process. The TEC scores the technical portion of each proposal according to the evaluation scheme established. The committee may not deviate from the established scoring scheme. Rather, each member should evaluate the prospective laboratory technical proposal. For more information on the process, refer to Appendix E.5, Proposal Evaluation and Scoring Procedures. Slide 16, Laboratory Selection and Qualification Criteria Technical Proposal Evaluation, MARLAP Section 5.5 continued. Please stop the recording and turn to the last 2 pages of the Module 5 handout. MARLAP Table E.6 is an example of a proposal evaluation plan. Take some time to read through this before resuming the recording. Although this is only an example, it will help to make clear how the process should work. Once you have read through this, please resume the recording. MARLAP Section 5.5.1.1 addresses the scoring and evaluation scheme. The RFP should include information concerning scoring proposals or weighting factors for areas of evaluation. This helps the laboratory to understand the relative importance of specific sections in a proposal and how the proposal will be evaluated and scored. The first element is technical merit. The lab's proposal in response to the RFP should include details of the laboratory's quality system and all the analytical methods to be employed by the laboratory, as well as the method validation documentation. The methods should be evaluated against the APSs and MQOs provided in the SOW. Previous performance should be reviewed and scored. The second element is adequacy and suitability of laboratory resources and equipment. If requested in the RFP, the laboratory will provide a listing of the available instrumentation or equipment by analytical method category. In addition, the RFP may request information on available sample processing capacity and the workload for other clients during the proposed contract period. Staff qualifications. The RFP should require the identification of key technical staff and their duties, along with their educational background and experience in radiochemistry, radiometrology, or laboratory operations. The laboratory staff that will perform the radiochemical analyses should be employed and trained prior to award of the contract. Related experience and record of past performance. The RFP should require the laboratory to furnish references in relation to its past or present work. Other RFP requirements. The laboratory's proposal should outline the various programs and commitments, QA, safety, waste management, etc., as well as documentation of various certifications, licenses, and permits to ensure that the requirements of the RFP will be met. The weighting of these evaluation elements should be established before the RFP is distributed. If no weighting is established, all items carry equal weight. Appendix E, Section E.5, Proposal, Evaluation, and Scoring Procedures contain more information on this topic. Slide 17, Laboratory Selection and Qualification Criteria Technical Proposal Evaluation. MARLAP, Section 5.5, continued. The review of the proposal for technical merit should include a review of the lab's proposed methods to satisfy APS MQOs for each nuclide matrix combination. It should also include a review of the method validation documentation to determine if method uncertainty specifications will be met, and a review of past performance in PE programs and internal QA program. Slide 18, Laboratory Selection and Qualification Criteria. MARLAP Section E5.3 addresses the weighting of evaluation elements. Here we have an example of what this could look like. We see 6 elements that will be used for the evaluation: technical merit, past performance, understanding the requirements, adequacy and suitability of proposed equipment and resources, academic qualifications and experience of personnel, and related experience. Each of these 6 elements is assigned a weighting factor based on their relative importance to the project. The anticipated weighting factors should be listed in the RFP. If the weighting factors are divulged in the RFP, the weights may not be changed without notifying proposals. For more information, see Section E5.3 of MARLAP. Slide 19, Laboratory Selection and Qualification Criteria. Pre-award proficiency evaluations are addressed in MARLAP Section 5.5.2. Some organizations may elect to send proficiency or PT samples, sometimes referred to as performance evaluation or PE samples, to the laboratories that meet a certain scoring criteria in order to demonstrate the laboratory's analytical capability. The composition and number of samples should be determined by the nature of the proposed project. Each lab's performance on the PEs can be scored and then used to rank or weight the lab's performance as a separate scoring element in the proposal evaluation scheme. Pre-award assessments and audits are addressed in MARLAP Section 5.5.3. The RFP should indicate that the laboratories with the highest combined scores for technical proposals and proficiency samples may be given an on-site audit. A pre-award assessment or audit may be performed to provide assurance that a selected laboratory is capable of fulfilling the contract in accordance with the RFP. The assessment should emphasize the ability of instruments, facilities, staff, quality system manual, methods, calibrations, etc., and the lab's potential to handle the anticipated volume of work. Slide 20. Laboratory selection and qualification criteria. Comparison of prices. Keeping the technical selection process separate from cost simplifies the process and helps sustain reviewer objectivity. Now prices can be reviewed and considered together with inspection results. This process is generally best performed by technical personnel, including members of the Technical Evaluation Committee who work either in a laboratory or in the field setting and possess a knowledge to recognize a price that is reasonable for a given type of analysis. There are various scenarios where it may be appropriate for prices to differ. The final ranking is based on technical evaluation, including proficiency examination and audit, and the best and final prices submitted by each laboratory. Candidates may be dropped, generally, if the proposed prices are extreme. Laboratories that score well aside from their prices may be given an opportunity to rebid with a best and final cost. While there is no way to determine how evaluations may be conducted in the future, some extra consideration may be given to proposals that offer greater technical capabilities, such as laboratories that house state-of-the-art or high-tech analytical services, as opposed to fulfilling the minimum requirements of the RFP.